Welcome back to another episode of Adventures in Machine Learning. I'm one of your hosts, Michael Burke, and I do data engineering and machine learning at this company called Databricks. And I'm joined by my co-host,
Ben Wilson. I try to figure out how to write CSS so I don't have to write JavaScript at Databricks.
Nice. Today we have a guest named James Lamb. We're going to be talking about some cool stuff, and this is why I'm excited. He got his master's in data science from Berkeley and has worked as a data scientist at a variety of companies. One of them notably is Amazon AWS, where he specifically worked in the IoT space. More recently, he worked at Spot Hero, which is basically a company that helps you find parking via machine learning. And then next week, he is joining the NVIDIA Rapids team. And now, because we love tooling on this show, we also wanted to highlight some of his open source projects. And specifically on the Python side, he's currently a maintainer of LightGBM, but also contributed to Prefect, XGBoost, and Dask. So, James, we were chatting a bit about this before we started the recording, but why have you done so much in the open source world?
Yeah. So first of all, thank you again for having me on. I really appreciate being here. Why have I done so much stuff in the open source world? I first got into it. I had a really good mentor who had done stuff himself and who sort of helped me to break through that wall of like, I'm not good enough. What could I possibly contribute? Like, how do I even get started? And once I got through that and saw like sort of the process, started to learn the etiquette, I got really into it for a couple of reasons. One, I just like to learn. And I found that having a project to work on, I internalized the things I was learning better than, say, like reading a book or an academic paper or something like that. I had a testing feedback cycle, like try to make it work, challenge my understanding in code. So learning was a big incentive. I wanted to just see if I could do it. I thought like there were these open source projects I used and respected, and I wanted to see like, could I do something to help them? Like, am I at that point? Have I learned enough like software engineering, stuff like that to help out? And just wanted to help generically. I felt like I'm getting to use all these projects every day in my job for free. It's awesome that they're free. I should help out a little bit. And then third, selfishly, I saw working in open source, especially as I like really started to get into it, as very helpful to my career. You sort of like working out in the open, you come into a job search with a resume that's on the internet for anyone to look at. Like no one has to believe me that I can do the things that I say I can do. I can point them to links and say, here it is. Like, here's a code. You could go look at it. Or you can go look at how I talk to people in writing. You can see what it's like to work with me. How I break down complicated problems into smaller pieces. So there definitely is there's a big selfish component to it. There is a reputational benefit that I get from the work I do in open source, and like a credibility benefit that helps me when I am applying to speak at conferences or meetups and applying for jobs.
Got it. Was there a reason that you started with the projects that you did? Because there's a lot of open source stuff out there. So why LightGBM and XGBoost and all these more popular repositories?
Yeah, I'll tell you the story. I like telling the story. So I didn't start with LightGBM. When I first started in open source, the first thing that I did, this mentor that I had at a previous job, he had an R package called DML. It was like a small R package. It was on CRAN, but not like a super high profile project. And he ran a little hack night for us after work. The company paid for drinks and food, and we sat in a room and he did like a 10-minute presentation. Here's how to contribute to open source projects on GitHub. And then he created sort of good first issue types of issues for us, paired us off into groups, and then we all worked together in a room contributing to them. So the first contributions I made were to his project. And I felt safe there. I knew the maintainer. I knew I could talk to him directly. I knew like he was my friend. I felt comfortable there. Once I sort of had done that and understood the process, the etiquette a little bit, and once this person I really respected, told me that his first 100 open source contributions were all of the form like fixing typos, adding tests, removing unused imports, stuff like that, I thought, okay, well, I know how to do that stuff. And I started like when I was learning things at work, going out and trying to find those things through GitHub search. So for example, like one of the tricks I used was I would learn something at work and then go find examples of that thing in the repos in the Apache GitHub org. So I learned at work like how to shrink the build size of a container image by combining multiple run steps into one step, right? So that you have like fewer layers. And once I learned that trick, I thought, okay, there are a ton of these Apache projects publishing Docker images that are intended to be used in quick starts. I can go like fiddle with their Docker files and make little contributions to shrink the size of them, and did a ton of, like a bunch of those. So I did that for a while. And my net of like, what projects do I want to work on, was just like anything vaguely related to data science, data engineering, array processing workloads, like anything like that, in the broadest possible definition of that. Through that process, I stumbled onto LightGBM. So at the company I was working at, Uptake, we were using R heavily on the data science team. And we were using XGBoost a lot. And some people on the team had been experimenting with LightGBM. LightGBM has similar design goals to XGBoost. It's used in similar ways. So I went to go look at the LightGBM R package, which was not on CRAN, the main repository for R packages. And I saw things that I could help with there that I knew from working on R packages at the company I was at. And it looked like the R package was not really like a main focus area for the maintainers. So I started putting up PRs there just to fix little R minutia, you know, the way the documentation is rendered, the way the dependencies are declared, like stuff like that. And eventually, after I did enough of those, they asked me if I wanted to join as a maintainer. I think, you know, that they saw that I was coming and doing good work, communicating well, that I sort of knew enough to be helpful with the R package, and that I was motivated to do this work that no one else in the project really wanted to be doing. They wanted to be working on other things besides the R package. So that got me into LightGBM. And once I got there, I sort of started to focus more on that project, expanding my influence in that project, like touching more parts of the code. Going and sort of trying to help a little bit on XGBoost was a natural next step because the project is so similar. In fact, like a lot of the code in LightGBM was originally copied from XGBoost. And so that was sort of the progression.
Got it. And just hearing you talk about all these small contributions sounds like a lot of work. What was keeping you motivated to contribute to all these? Was it building that resume that you described, or was it just fun? Why were you doing this?
I think in the beginning it was about learning and getting better at the things that I was using every day in my day job. So I wasn't really thinking that open source would ever be something that would show up on my resume, something that would define my career. I really was just thinking these things around machine learning and writing R and Python and building libraries. These are things I have opportunities to do in my job. And if I can get better at them, I'll advance in my job, you know?
I have a very weird question for you,
Right.
but related to how working on open source might influence your own skill set. Have you found that there's a difference in code sanitization, design, and readability in open source projects versus something that's closed source?
What I have found generally is that open source projects, and here I'm talking about libraries. So I haven't worked on, say, like an open source service like Mastodon or something, right? Libraries, they tend to be more flexible than would be justifiable in a closed source proprietary setting. They tend to need to support more sort of hooks. I mean, you were talking about MLflow. I'm sure you see this in MLflow, right? Like there are so many integrations, like different logging setups for the different types of machine learning frameworks. In something closed source where you're only using like a much smaller subset of things in and around that piece of software, that flexibility isn't justifiable, right? You don't need all of that.
Right.
Another example I think of is like the Apache Airflow project is a great example. If you go look at Apache Airflow, and you see all of the providers. So the way that Airflow sort of manages integrations with other services is this set of libraries called provider libraries that sort of hook into the core Airflow APIs and like present an interface that looks like the rest of Airflow's interface, but that knows about the details of, whatever, the Databricks API for running jobs or Snowflake or whatever. I would be very surprised to learn that any company is using even 50% of those providers.
Right.
But there's no way, right? But the maintainers of that project, they need to have a process for triaging reports, for testing, for updating dependencies, for every single one of those, because all the providers are vendored in the same monorepo. So that just as another example, I found that in general, open source projects tend to be more flexible than their closed source equivalents. And what that means is there's necessarily a higher testing burden. It's more difficult to test every combination of those different features, those different capabilities. And so sometimes it can feel like open source projects are not as well tested as the ones that are written by people being paid money to write something closed source in a company. But in reality, like you should probably expect for any popular open source project that the main code paths that are used by most people are heavily, heavily tested. And of course, like tested out in the wild by people using them and then reporting bugs, right? So yeah, does that answer your question?
Yeah, I mean, the thing that I've found most interesting after looking at many hundreds of repositories in closed source over the years, other companies' stuff and things that I built, both abominations and not so terrible repos. I found that when I stepped back and looked at something like you mentioned, XGBoost, it's a pretty readable library. Like when
Yeah.
you go in there and you look at how it's not excessively sophisticated. It's not like, hey, we're trying to flex, the big boy programmer flex. So
Yeah.
like, look how good I am and how much of an elite coder I am. There's none of that. And there's an intention by open source maintainers and developers to avoid that. And I was just wondering if you had the same experience that I've talked to a couple of contributors for MLflow that have said, hey, after I did about, 30 or 40 contributions, I noticed that my code that I'm writing at my company has gotten more readable and people have noticed that. So it's
I,
like that bleed over effect. I was just wondering if you'd experienced that as well or
I
seen
think
that.
I think I have experienced that personally in my code. I think especially working in open source has given me this like paranoid obsession with limiting complexity.
Yes.
I think that's the way I would describe it. So before I started working in open source, and like, yeah, I think I was, and I need to remind you, I did not study computer science in school. I went to business school, studied marketing and econ, did not write one line of code in undergrad. So when I got my first job where my title was something data scientist, that also was just like 2-ish years since I had written my first line of code. So I also was trying to figure out, do I want to keep going in this, doing software engineering? Anyway, before I started working in open source, for sure, there were ways that I approach problems that today I wouldn't do. For example, like that temptation to modify the behavior of a library by adding one more Boolean flag to do the thing that you want, right? Like, oh, well, I want this to return a data frame instead of a NumPy array. Return data frame equals true. Like that, it just seems so simple. It seems like, let's just do this. But working in open source, I've learned like those things, they can just destroy a project in terms of the complexity that they put onto the system, the explosion in the number of code paths, or even just like I've learned to be paranoid about required dependencies, about like, oh, well, I'm doing this thing with this library and I also wanted to make plots. Let me just like throw Seaborn in here and let me throw like all this stuff in here. Great libraries, like nothing against that project. That's not what I'm saying. But I've learned to think like maybe plotting should be separate from the core library that has to run in all of our services and has to be built successfully to run our business. Stuff like that. So it definitely has changed the way that I write code, the way that I think about it. I want to tell you one other way that I think working in open source has really changed the way I work in like proprietary setting. And I think that that is the way that I communicate asynchronously in pull requests, commit messages, tickets describing work, stuff like that. So when I joined LightGBM, um, I was the only maintainer who was a native English speaker. Everyone else in the project spoke English as a second or third or fourth language. And I was the only maintainer in the Western Hemisphere. So I found myself communicating mainly in writing asynchronously with people who had learned a very formal form of English compared to like what I learned in the south suburbs of Chicago, and who were in a different time zone. And so I found that to communicate effectively asynchronously with them, I needed to be proactive. I needed to anticipate their follow-up questions to cut out the number of feedback cycles. So instead of saying in a pull request review, leaving a comment that's like, why are we doing this? Instead, I might write like, hey, I noticed that you chose like this API from Pandas, but I noted, but in the documentation, it's actually marked as deprecated. I think we should do this instead, and here's why. What do you think? Something like that, and that I really think has helped me in my day jobs. That learning how to like anticipate what people's reactions will be, cut out cycle time, and when I put up proposals, when I put up pull requests, to not just describe this is what's changing, but to describe all the context that reviewers need to understand why. Like to say, here's why I went this way. Here's the things I want to call out as potentially controversial and why I made these choices, etc. So I think that that has affected the way I work as well.
I think that's an excellent point that a lot of people don't really talk about that much. And there's some teams where that's so ingrained in the culture. And specifically what I'm talking about is the code review, pull request review, peer review, where you as a peer of somebody who's checking in code, whether they be an external contributor or somebody who sits at the desk next to you, it's a skill that doesn't get enough attention, I think, about how to properly do that in such a way. The example used is perfect. How many times have we all gotten comments like that? Like, what the hell is this? Or are you sure that this is a good idea? Question mark. And the person on the receiving end of that is like, well, now I don't think that that's a good idea, but I don't know what context you're exactly speaking. You highlighted a line of code. Now I have to go and think through this. And when you're, mentoring somebody, that can be a good tactic, depending on the person who's the mentee. If they thrive under that, like, oh, I got to go learn this. Like if I'm going to do that to somebody, I'm going to do it to Michael because he loves stuff like that. He'll go off and figure it out and then come back and fix it. But not everybody responds that way. And when you're talking to somebody who's halfway around the world that you don't actually work with, the way that you handle that interaction is critical, not just for your relationship with that other person. And you brought this up at the beginning as well, in your selfish motivation for open source, which I don't think is that selfish. I think it's just smart. But people read that. If you're marked as a maintainer and people know you're a maintainer of some very popular open source package, if you're being flippant or short or rude in your PRs, people are going to be like, oh, I don't want to file a PR with this person reviewing my stuff. Like they're such a jerk. And it just poisons the well. So being professional, but also being helpful, saying, and also not being dictatorial, but saying exactly as you put it. I love seeing PR responses like that from maintainers, where it's like, I see what you're doing. Could we potentially try this instead? Or here's 3 options that I think might work better. Which one do you think is best? And put it back in on their side. You can word it in such a way that they're going to be like, oh, I'm going to take this one because this is pretty obvious. But yeah, I think that's super important. And that's something that will also help build an effective career and a reputation within a company and an industry when you're talking about open source.
Yeah, thank you for that. I do try to be very intentional about that, and I like the word you use, like not being dictatorial. I feel when you're making decisions about technology, whether it be like inside a company or in an open source project, you get to a better decision that everyone is bought into more quickly by not just saying like your position, but also exposing your thought process a little bit, exposing that to criticism too, you know? So when I'm asking people to change things in like who come in open pull requests in LightGBM, I do try to be intentional about explaining why I'm asking for what I'm asking for. And sometimes what that leads to is I'm wrong. Something about my assumptions was wrong, and I learned something. I'll give you an example. We have had this awesome outside contributor showing up in the repo for the last couple of months, adding support for Apache Arrow formatted data throughout LightGBM's Python API. And he recently added something where he was only adding support with PyArrow tables or something like that. And I said, well, hang on, like, couldn't this also be a PyArrow array? Don't PyArrow arrays? I thought that PyArrow arrays could be two-dimensional. And he came back and was like, no, actually, they're one-dimensional. The 2D thing in Arrow is a table. And there, like, I learned something. And because I think because I phrased it in a way that was like, hey, here's my understanding, but I might be wrong, he doesn't walk away, I hope, feeling like, well, like, these people don't know what the hell they're talking about. Why am I working on this project? You know?
Yeah, it's all in the presentation. I think in a pull request as a reviewer, and the nicer and more humble you are, particularly if you're a maintainer, yeah, the more people want to actually contribute. And if you're somebody who's open to learning, which all of us who maintain projects like this, like we're learning stuff every day from contributors.
Yeah.
I mean, at least I do. You're always seeing like novel implementations of something, or you ask for further clarification and somebody educates you. You know, it's like, actually, this is how this works, and here's some links. I'm like, this is so cool. Like, I love working on stuff like this because you just have this global network of people that are willing to just collaborate. And I have seen projects where somebody does that well poisoning, where you look at their response to somebody's contribution, even if it's something silly. You mentioned stuff with like good getting started, good first issues that open source projects that are well maintained will issue. And that's to get new people in and to make it easier for people to get past that same psychological hurdle that everybody has. It's scary when you first do that, your first PR, and something that you're like, hang on, how many millions of downloads does this thing have a week? How many people are touching this? And I'm filing this, that people know who I am. Like, that's my name right there.
Yeah.
So those good first issues are great, where it's like, hey, can you add some docs to this, or to explain this process a little bit better, or add a tutorial. I don't know if that's good first issue. Those are usually a little bit more complicated, but some of those initial things to get people into your project, I've seen in some projects, maintainers just trash people on the PRs.
Yeah.
And you just read it and you're like, what are you doing? You just removed this person from your contribution pool, and probably 100 other people who read this and are like, well, I'll find a different project to contribute to.
Yeah, you know, and I'm really sympathetic to the fact that like a lot of projects are maintained by people on nights, weekends, not in their day job. That's certainly been my experience with LightGBM. And I have, you know, I feel like I've seen projects where they basically say that they're closed to outside contributors, that they are sort of like source available, you can report bugs, but they're not going to review patches. I actually think that's okay. I think that sets the right expectation. Like, look, we don't have the capacity to support external contributors, and we're taking it's our like we're calculating that risk is worth it in exchange for not getting more people into the project, not like building up the set of people who feel invested in it. But yeah, those projects that don't do that, that say that they're open to external contributors, and then where people are abrasive, where they're rude, it makes me sad when I see it.
So we've been talking a lot about sort of maintaining projects. How do you guys think about incepting a project and sort of developing it from scratch so it's built for not only wide use but effective maintenance? And it's a like a pandas or a numpy or a LightGBM or a MLflow. It's one of these monolithic and like extremely important uh, default tools. How do you think about starting? Do you start with a business problem? Do you start with a team of really good people and just start building stuff and hope it sticks? How do you think about it? For both of you too.
I mean, I think all of those projects that you mentioned either came from academia because they were needed for doing like this new research with this language, or they were a byproduct of somebody who wanted to make something much easier that they were really struggling with. You look at something like pandas, right? Pandas was basically started by one guy. Great guy, built something that's so heavily used in the world of data science, ML, analytics, and you name it in Python, somebody's probably touched it and installed it. And it's a wrapper around NumPy. And NumPy is a wrapper around a bunch of C libraries that do data manipulation and array iterations and stuff. Because the guy who created that was so frustrated with having to write all this code in NumPy to do what he was trying to do, just table manipulations and basically doing what you could do with SQL within Python. He was like, I'm going to write an abstraction layer that makes this simpler, that makes it feel like these other tools that were out there. He was just the first one to do that and do it well enough that people were like, this is awesome. And it integrates with all these other things because it's speaking the same language that those other platforms speak, which is NumPy, which is the standard. But when you talk about frameworks that have come along since then, that you're not the first one to get there, because Pandas has staying power. It's been around for a while. It's not going anywhere. It's only getting better as time goes on. But if you're trying to start something right now in an ecosystem like Python, and you're like, hey, this is going to be the pandas for this particular use case, you're only really going to see that with an organization. So look at the major open source contributions that are out there. They come from big tech companies that have a lot of people focused on a particular problem. The only time that a business is going to do that is if it's an actual worthwhile problem to tackle. So LightGBM came out of Microsoft research. They had an entire use case centered around that they wanted to solve, and a whole bunch of customers that wanted to freely use the open source version of this package. So they give it away for free and invite external maintainers. Databricks with MLflow, Databricks with Delta, a bunch of other stuff, Apache Spark, right? These frameworks that are out there, they're so successful because it was a group of people trying to solve a problem from a general perspective that then just gets given away for free.
Yeah, I definitely agree with that. And I think that that's a story that's been told many times of projects that began inside of an organization to solve the organization's problems that grew out of the organization to get a more sustainable support model so that they could keep up faster, so the organization could focus on the things that it does well. Like I think about the story of Apache Kafka coming out of LinkedIn. Kafka was very successful for them, like using event driven sort of processing, like was successful for their business goals. But at some point they thought, okay, like our business is not running like this basically message passing system. Like our business is helping people find jobs and helping people connect with their coworkers. And for them, open sourcing that project was about keeping it going, keeping it receiving security patches and updates as new language versions came out, and allowing them to focus more on their core business. So yeah, that the way that you described it, Ben, totally resonates with me. I I wanted to answer this from a slightly different perspective. Like another part of your question, I think, Michael, was how do you make it such that like people will come and contribute, right? Was that a part of the question?
Yeah, definitely.
I will tell you my approach to this is linters, linters, linters. And I know it sounds like really tactical and specific, but let me tell you why. I think that there is just this thing in human psychology that we are like more willing to take critical feedback from machines than we are from each other. And I have seen this play out over and over again in my career that like I will leave a pull request comment saying, hey, can you add this type hint or can you do whatever? And occasionally people will be like, nah, do I have to? Like, I don't think it's important. I'll just do it later. But I've never once seen, say, like MyPy report that something was untyped and have someone say, could I just not do this? There's just something different there. I really, really believe that getting people automated feedback on their contributions improves the process for people who are trying to get into a project. And that means, yeah, it means static analyzers. It means like other code linting. It means unit test coverage. And it means sometimes if there's not like a pre-built linter for the thing you want, just taking sort of the things you want to be true and turning them into stupid little shell scripts that fail CI builds. I've done that before. Like I just did one of those in LightGBM. We, for example, wanted to enforce like a certain pattern for our OpenMP pragmas in our C and C++ code. And the easiest way I could think to do that was just write like a tiny shell script that runs git grep and checks all those pragmas and fails builds if anything doesn't match the pattern that we want. So I really, really believe having automated fast feedback is important to getting people to have a good experience when they come to contribute.
Yeah, I mean, it's the same thing as like checking out on an online e-commerce website. You want to reduce friction. And by bringing machines into the development loop, you're reducing friction and not having a human have to do all that, maybe wait 24 hours. Or as we described, like if you're working with distributed teams, they're on different time zones. So waiting 12 hours, you lose context. You have to re-enter the context. So it makes a lot of sense.
Yeah, and you don't want to ever give people the experience where they get different reviews or different like expectations set about what's required based on which person happens to pick up their pull request, right? That's not a fun experience. That makes it feel like you're just guessing. It makes it feel like some of the things that you're being asked to do are just one maintainer's personal preference and not like sort of a thing that's necessary for the success of the project. So yeah, the more, and I think about this in companies that I work in, like, you know, when I work at my day job too, I'm not a big fan of, say, like, we have a wiki page internally with a style guide and we all agree to follow it. Like those things, they're just too much effort. There's too much stuff you have to keep in your mind. There's too much human effort involved for a type of problem that computers are good at solving, which is just like, we all agree this is what the code should look like. Your build fails if it doesn't. I really, really am a big believer in that.
But you still need human reviews, right?
Of course. Yeah, of course, right? Like the things that what are the things that are difficult to automatically express in static analyzers? That is like the expansiveness of the API. Like, do we even want to support this functionality? That is like, I don't know, a version of a dependency being pinned to something that's too new, or something like that. Like that's kind of hard to automate, right? Consistency between two different APIs, one of which isn't controlled in the repo. You know, for example, like in LightGBM, we have scikit-learn compatible estimators that sort of try to offer an API into LightGBM that looks as much as possible like the scikit-learn HISC gradient boosting classifier, random forest classifier, whatever. That sort of compatibility. I mean, scikit-learn does have a bunch of tests that they export that projects can use for that. Maybe that's a bad example now that I started talking. But in general, yes, there's a whole class of problems that require human review, and I think always should. The way that I like to describe it, the pull request review process is like this. When you are presenting code to a human maintainer, someone that you work with, another maintainer of the project that you're contributing on, or one of your coworkers in your job, this is not like taking a bag to airport security and the maintainer checking that it's allowed on the flight. It's more like you and someone you're traveling with packing a bag together, right? And both agreeing, yeah, we're going to carry this with us. And I think there's always going to be a set of problems that require that.
I couldn't have said that any better, even if I tried.
Thank
You know, that process of just using CI, you know, if I'm an outside like somebody who's trying to contribute something to a project, and I know that people aren't really looking at PRs that closely, you could fake a unit test. That's not it's named whatever the feature is, and if it's not thoroughly testing what that actual implementation is, it's probably just going to pass, or you can make it pass effectively with not really validating the functionality of that feature. So there's no system that's going to catch stuff like that. You know, you require a human to be able to understand what is being implemented and verify that the tests what it should be testing, that you're not just mocking the world and testing this one little thing. So it's really critical to have an experienced person who's doing that. But I really couldn't agree more with the linting stuff. And I'd add one other thing to that: pre-commit hooks. So the thing that advances that from being frustrating to being like, hey, thanks robot for fixing all of the stuff that I screwed up with typos, not sometimes typos, but other times just structural changes. And yeah, I also absolutely hate style guides. I think they're so stupid because nobody can conform to them. It's too much, cerebral load for any team of people to align on. And you're just going to get nits constantly. Nits are fine on a PR if somebody has a typo, they misspelled something, or they forgot a word, or the sentence is a fragment or something in like a doc string. But when you have people that are saying like, this should be 4 indentations, not 2, and then somebody else saying, no, this should be 2 indentations, not 4 for Python. It's like, yeah, they're both valid. Just pick one. Have your linter do that and reformat your code. Use black. End of the story. If you're writing Python, use black. Use pylint. Use pre-commit. Hooks that are going through and validating that the structure of your code aligns to the standards that you're setting as a project, and then publish those, and then make it so that contributors can install that exact version of that linting stack, so that before they even push to their fork with their PR that they want to file in their local terminal, the files have already been reformatted for them. Because people don't get frustrated with that. I couldn't agree more with you on that, James. When a computer tells me that something's messed up, I'm just like, you're the boss, like style guide. I really don't care if I'm writing it perfectly. That's what the linter's for.
Yeah.
Yeah, and having those tools available is great, and it really lessens the resistance to getting those first 10 to 50 PRs checked in.
Now, James, I have a question for you because we all know Ben's opinion based on the last 15 episodes. If you've listened to any of them, you'll know the answer. But what is your thoughts on leveraging LLMs to give feedback on code?
I know absolutely nothing about large language models, so I'm probably not the right person to ask that. Sorry.
Cool. Is there a reason why have you intentionally avoided them, or?
Yeah, I mean the domains that I've worked in my career so far, when I was working as a data scientist, mostly involved time series data. That was macroeconomic data, financial data, sensor data from equipment. I just didn't really work on natural language processing or say like video, computer vision stuff. Just wasn't a thing that I did in my career so far. Maybe I will learn about those things at some point in the future, but for now, I have nothing intelligent to say about them.
Got it. Okay, cool.
I would say that would be a blanket statement for a lot of people, even though there's a lot of people that have a lot to say about them.
Yeah, sure.
I mean, that is fascinating to me in some respect, though, and I think it's a lesson to be learned for some people out there. You know, you're a professional contributor to multiple open source projects that those are big names. You know, these aren't small little one-off like, hey, my buddy Bob has a GitHub repo with 3 stars on it. And it got 10 downloads last month. No, you're talking millions of downloads on these things. You know, lots of people are using these. So for you to say like, yeah, I don't really know that much about it, don't really not invested in it, but I'll learn it if I have to, sort of thing. I think there's a lesson to be learned there, with people focusing on uh, what's important for what they're trying to work on, and it's another thing that brings to mind a question that somebody asked me last week, which was, do you think that, how did they phrase it? They said, like, do you think that traditional old school data science is going away because of LLMs? And I was actually dumbfounded at the question. I didn't know how to actually respond to it at first. And I was like, I had to ask some questions to them, saying,
Yeah.
like, what do you mean, like, going away? I mean, they're all using the same fundamental algorithms and the same fundamental, like, C++, Fortran, Haskell code powers all of this stuff. So I don't know what you mean going away. And they're like, well, Transformers model that could do like what XGBoost does. Like, I'm not sure how to respond to that. Like, and I just asked them, I was like, how does, gradient boosting work? And how is a decision tree constructed? How does it do that split decision logic for histogram bucketing of, continuous data? And we got into that discussion a little bit, and I was like, could these advanced generative models learn that eventually? Sure. It's going to have a lot of training data that contains the understanding of how to apply mathematics to a data set that comes in, and then have some sort of execution framework to do that. So an external service that's, a mixture of experts. But what people who focus on the hype train fail to realize is what you described that you spent most of your career doing, from my personal experience as well. That's probably 98 to 99% of deployed ML globally, is stuff like time series models, regression models, tree-based logic, and then some of the fancier stuff like LightGBM, XGBoost, these sort of gradient boosted trees and forests. But all of that traditional ML, that's what powers most of, the modern economy when we're talking about how data science impacts it. I don't think that's changing anytime soon.
Yeah, I can at least tell you from my perspective, the downloads of LightGBM's Python project, the volume of people submitting issues has not changed meaningfully in the last 4 or 5 years. So people are still out there using it in their day jobs. And if that at some point is no longer true, yeah, like I said, I'll learn new things. I'll go where I need to go,
Yeah, that makes sense. Okay. So another question is regarding open source, as we were talking about sort of policies to make the open source contributions good, and also how to sort of initialize a project so it's useful. How do you think about the communities around open source? Because I saw that you are very involved in the MLOps community in Chicago. Do you have buddies from open source? Are they just a username on a screen to you?
Yeah, really, really interesting question. I have definitely made some sort of internet friends in open source. People who I've just talked to in GitHub comments, GitHub issues, in maybe like open source Slacks or Discords or stuff like that. People I've never met in person. People who I don't know anything about their their family, what they like to do, their background. We just kind of talk about the projects. I definitely met people like that, which has been interesting. I have some people that I know a little bit better that for example, like one of the maintainers for LightGBM, he joined 2 or 3 years ago, Jose. He actually was one of the people that I put forward as a reference for me in my recent job search. So we talk in Slack sometimes. Like we know each other at least a little bit better than just like random people that I talk to on GitHub. Outside of that, I really, really like going to meetups. I'm lucky to live here near Chicago. It's a big city with a lot of tech jobs, tech, professionals. And so I'm lucky that we have good meetups. We have the Chicago Python group and the, this MLOps community thing that my friend Ankush and I run, and a couple of others. I like meeting people, hearing what they're talking about. I do think that hearing talks at conferences and at meetups that are not from vendors, that are from practitioners, is a really, really, really valuable filtering function, right? There is, for all practical purposes, infinite of information available on the internet about every topic around data science, data engineering, machine learning, Python. Hearing someone get up and give a 10-minute talk where they say, hi, I work as an engineer at XYZ company. We had this business problem. We chose these technologies and it worked or didn't work. And here's why. That is so, so, so valuable for filtering out sort of like what works and what doesn't, learning the patterns. So yeah, I really like that community aspect of it.
And you feel like you learn more via in-person meetups versus, let's say, reading a textbook or even watching a YouTube video?
I'd say like the textbooks, watching YouTube videos, Coursera courses, reading the long form docs, those help you to go deep. I remember seeing like a random tweet go by a couple of years ago. I don't remember who it was, recommending that like you read the documentation for an open source project you use from beginning to end, instead of treating it like a dictionary where you look up just the thing you need. And I've done that 2 or 3 times. And like, if you can carve out the time, it does help a lot. Like, for example, I remember reading back in 2016, I read the O'Reilly Guide to Elasticsearch on a couple of flights on a trip and learned way more about Elasticsearch than I ever needed to know, but came out of it like understanding a lot of stuff. I think that those things can help for going deep, but to be agile, to be adaptive as the world changes, it's really important to have exposure to a wide breadth of technologies, to at least be able to explain in like a 1-sentence way what each library, language, framework, technique, whatever is. So you can at least like have some shared vocabulary when you talk to people. It's for that purpose, for like getting that wide exposure, that I found meetups and conferences to be more useful. And I think that's because the content isn't as personalized to me. I'm not searching directly for something or being served something that like an algorithm thinks I'll like. I'm just saying, this conference is vaguely about data science. I'm just going to go listen to whatever the talks are. Or, I went to the SciPy conference in Texas this year and last year. And some of the talks there are people who are doing like materials research, or they're like launching satellites into space. But they talk about, they talk about Python, scientific computing in a totally different way than happens in my sort of bubble, my part of that world. I found that exposure really, really useful. In fact, I'll tell you, like, one thing that helped me to get started in my data science career was doing this. I used to go to the Open Data Science Conference, ODSC, twice a year, in Boston in the spring and in what I thought was San Francisco, but was actually the SFO airport hotels in Santa Clara in November. And I go to these talks, and when people were talking, whenever they mentioned an open source project, framework, a statistical technique that I hadn't heard, I just wrote it down in a bulleted list in like the back of my notebook or whatever like thing I was taking notes on my laptop, and then went back to listening. And then after the conference, I went back through all of those things and Googled them and at least read like the README. I think that helped me so much to be able to talk with more people in the tech world, to see like the patterns between these different projects. And I really would recommend that for anybody who's feeling like they want to learn a lot.
That adds up. Nice. Yeah, my personal experience is I don't like conferences whatsoever, but they are really good to, like, while you're waiting for your friend to talk in 2 hours, you just pop into a talk on distributed computing with Ray or whatever it might be. And you start learning a little more than you would if you had a very controlled timeline on a computer where you can do whatever you want. There's no sort of downtime. There's no twiddling your thumbs. Actually, at the Data and AI conference for Databricks I attended this year, I started chatting with one of the lead ML engineers when I was waiting for Ben's talk, actually, at JetBlue. And we were learning about the framework that they were building. And it was just, now I sort of know what JetBlue does for ML. It's interesting. So those sort of happenstance water cooler talk type of situations are really valuable to get breath, and also just like learn things that you might not otherwise.
Yeah, definitely. And I think Ben was mentioning it too, that it's something you can learn through open source too. People show up with issues and pull requests, and they're like, oh, I need to make this work on Manjaro Linux. And you're like, oh, what is Manjaro Linux? Now I have to go learn something, you know? That I found that to be really useful too.
Yeah, makes sense. Cool. So we're at time. I will quickly summarize and then kick it over to James for any next steps. So lots of cool stuff about open source. If you are looking to get started with open source, so you can do sort of some basic PRs. Some examples are fixing tests, removing unused imports, and just sort of doing baby steps until you're more comfortable with larger PRs. Regarding the PR review process, if you're sort of an owner or a maintainer of a repository, you should try to automate as much as possible. Linting and more generally pre-commit hooks are a great way to do this because they reduce the iteration cycle for a developer. And also, people weirdly like feedback from machines. They don't like it from people. Another thing is, it's not a great idea to try to strongly adhere to style guides because there's so much complexity, and depending upon how well a reviewer knows a style guide, you might get different responses. So it's better to have sort of general practices and try to automate as much style as possible. And then once all that is done, give it to a human for high-level design review. Then some sort of miscellaneous tips. If you're communicating offline, try to anticipate reactions. This is something that I've been really working on, and I frankly get kind of frustrated when customers that I'm working with are just bad at communicating offline. Like a one-word question, why, how, what. It's like, don't even respond at that point. That's an extreme point, but I don't know. Yeah, sort of anticipating reactions and then looking to guard against what their concerns might be. It really reduces the number of iterations required to reach a solution. Regarding the Python open source market, it's pretty saturated. And so typically larger organizations like businesses and universities are the ones that are going to come in and make new things. But it doesn't hurt to try. And then finally, as we discussed, in-person conferences are good for developing a breadth of knowledge. So James, if people want to learn more about you or get in touch, where should they go?
Yeah, absolutely. So my GitHub username is James Lamb, no underscores, no dashes, just James Lamb. I have all my other contact stuff up on my GitHub README. And especially if you are interested in contributing to LightGBM, we have way more work to do than people to do it. You do not need to understand everything about the project to make meaningful contributions there. We will help you through the process. So please come by, or if you're not like feeling super comfortable just submitting a PR, you can message me at any of the places you see on my GitHub, and I'll help you through the process.
Awesome. Well, until next time, it's been Michael Burke and my co-host,
Ben Wilson.
And have a good day, everyone.
We'll see you next time.